Okay, for the first common mistake here, this I see this all the time when I'm marking papers is just the penalties. Now they don't give specifically penalties anymore as of November 12th exams or something like that, but it's basically the same thing. And what I'm talking about here is accuracy penalty, unit penalty, and financial penalty. Okay, so accuracy of your answers. The important thing to remember here is that unless they say otherwise, you got to go to three significant figures. Okay. Now, they've changed this from the class of 2013, and it's good for the students. Okay, so look at number one. It says if the candidate's unrounded answer is seen and would round a three significant figure answer, then award A1 and ignore subsequent rounding. So what that means basically is you should always write down your unrounded answer in your working box. If you write that down, you'll never get a penalty, which is beautiful. Okay, then you can round it if you want. If you round it improperly, it still won't matter. Okay, so I tell my kids if they're unsure just to write down the whole answer. But obviously you should be able to round to three significant figures. Okay, now another thing is if you round your answer and you're going to use that rounded answer in further parts of the question, make sure that you show your work. Okay, because especially if you round it wrong and then you don't show your work, the IB examiner can't go through your work and assume that that's what you're doing. So you really have to show your work, okay? A lot of my kids don't do that, and it kills them, okay? So if we're to look at this down here, this is just a summary of it. So you get your unrounded answer seen here. It's correct, A1. It's three significant figures. It's cool. You get an A1. Incorrect, you get an A0. Obviously, correct to two significant figures. They'll even give you that. Then all the rest is wrong. Okay, so make sure you do that. Now, with finance questions, this used to be a finance penalty. They will usually, the answers, if they don't say anything, put your answers to two decimal places. You just have to assume. Normally it's euros or dollars or something, yen maybe. So it's going to be two decimal places. But oftentimes they'll ask you to round to the nearest whole unit, okay? So again, you can lose 1 mark per paper, just like in the accuracy penalties. In financial questions, you can lose 1 mark per paper. And then I'm going to go over, units in just a second. And you lose one of those on each paper. That's 3 marks on one paper, 3 marks on 1 paper 1, and 3 marks on paper 2. That's brutal. That's 6 points. That's like 2% of your grade almost, or actually more than 2% of your grade. It's almost 2.5%, 3% of your grade. That's your final grade in IB for not rounding properly. So make sure you do that, okay? And then finally, units, okay? The kids forget to put units on their papers all the time, and it's annoying. There'll be specific questions for which units are required, and this will be indicated clearly in the mark scheme. Okay, it's not going to tell you on the test, but if you're trying to find distance, for instance, that's going to be kilometers, meters, centimeters, something like that. If you're going to find area, it's going to be meters squared, kilometers squared. If you're finding volume, it's going to be to the third power. Okay, so like meters cubed. Okay, now again, you can only lose 1 per paper, but don't. It's a stupid mark to miss. Okay, now just be careful. Like you got to look what you're finding. If you're finding area, make sure it's squared. If you're finding volume, cubed again, or just distance. So what will happen oftentimes is, say you're finding area, and a kid will put 200 kilometers. Well, you're not going to get the final A1 on that question because it should be meters squared or kilometers squared, whatever I said, instead of just kilometers. Okay, so that's the first thing. So just be real careful. Like it's 6 points in paper 1 and paper 2 that you can lose on accuracy, and it's a shame. You really shouldn't lose anything. And some kids don't take it seriously, and I've had kids who've been off by they missed the boundary by 1 percentage point in their final marks and their final grades, and I have no doubt that it's because of accuracy penalties. Okay, so yeah, just pay attention to that. Okay, thanks. We'll move on from there. Okay, for the second common thing, the mistake that I see kids make sometimes is just not showing their work enough. The IB is real generous with giving follow through and method marks, and especially on paper one, kids tend to rely on the calculators, which is fine. But you always want to show your work. Okay, so I took a trig problem here just because kids, trig always seems to be a tough one. We gave this problem to our kids, and they kind of struggled on it. So let me go over it. Tom stands at the top T of a vertical cliff 150 meters high and sees a fishing boat F and a ship S. Okay, fine. B represents a point at the bottom of the cliff directly below T. The angle of depression of the ship is 40, and the angle of the depression of the fishing boat is 55. Okay, now the thing, angles of elevation and angles of depression seem to confuse kids. Now, if this is 40 here, you have parallel lines. You have this line right here and this line are parallel, and so these are are called alternate interior angles. So if this is 40 right here, this is going to be 40 right here. Okay, now I'm doing this without even looking at what they're going to ask here. I mean, I've seen this question before, but just on the information. So I want, because I want to get some of the angles in these triangles. Now they're saying the angle of depression of the fishing boat is 55, and this is where a lot of my kids messed up right here, is 55. This is 55 degrees, this whole angle right here. So that means that this is 55. Okay, so now once you get this, this question turns out to be pretty straightforward. Now, it says calculate SB, the distance between the ship and the bottom of the cliff. Okay, so SB is right here. Okay, so we're gonna calculate that. Now we have a right triangle here, so we can use SOHCAHTOA. Now I label my working. Okay, make sure you put A. So the IB examiner, if you get it wrong, they can look for method marks. Okay, some kids don't label it. Okay, so what I'm gonna do is, if I have 40 degrees here, I have the opposite. And I have the adjacent here, so that's going to be tangent. Okay, so I'm going to say the tangent of 40 degrees equals 150 over x. Okay, now if you're going to do this, just do 150 divided by tan 40. Okay, that anytime the x is on the bottom, you're going to divide by the number. Okay, and we'll go to the calculator. And now I'm turning it on, and I always say this, but just make sure you're in degrees, okay? We reset our kids' calculators to degrees, but I don't know that everyone does that. So you always work with degrees in math studies, okay? And that's really important. If you use radians, you're going to get some messed up answers. Okay, so I'm just going to do 140 divided by 150 divided by tan 40, okay? And what do we got? 178.7. Now, do they say to the nearest anything? Okay, so it's going to be, to three significant figures, that's 179 meters, okay? Now, again, you want to make sure you put your label. So it's going to be 179 meters, okay? So you'd get a penalty if you didn't put your label. So what I would do here is I'd put my answer 179 meters, okay? Now, let's look at part B here. It says calculate SF, the distance between the ship and the fishing boat. Give your answer correct to the nearest meter. Okay, so here they go. Okay, so now they're saying correct to the nearest meter. Okay, so that's huge. That's a rounding right there. Okay, so what we need to do there is first, this is a strategy. They want FS. Now, a lot of kids will try and run through and do all this, find this right here and blah, blah, blah. Basically, the way to look at this is you have two triangles. You have this big triangle here and you have this small triangle here. Again, we can find BF right here. So if we find BF and FS, so we already know SB or BS. Ha ha ha. That'd be funny if they said BS. That'd be ironic, right? Okay, so anyway, okay, I digress. I always digress in these. Okay, so I'm going to find BF first. Okay, or BFF. I'm just on fire today. Okay, so I'm going to do tangent 55 degrees equals 150 over x. So it's going to be 150 divided by tan 55. Okay, and what do we get there? Okay, so, whoops, that's the wrong paper. So 150 divided by tan 55. Okay, it's 105. Oh, it's 105, and that's nice. Okay, so it rounds to 105. Okay, so you just have to be careful. So 105 meters. Now, that gets you the first couple marks. Now, what do they want? they want to find, so we're just going to have to do 179 then minus 105, okay, which would be 74 meters. Okay, so again, it's 74 meters. Now, you see what I did there is I prematurely rounded these. Okay, that in this case, it's fine. And I knew it was fine because I was looking at the answers, but let's look back at this. Okay, if we did, you really got to be careful doing that. Like, in fact, I shouldn't have done that. So if I'm going to do 178.76, I'll just, I'll do it to a couple decimal places, minus 105.03. Okay, now it's going to be the same thing. So, in fact, I can just do, 178.76 minus, and I'll just minus the answer. So second answer's right there. And I get 73.7. Okay, so it's going to round to the same thing, but you just got to be careful with that because sometimes if you prematurely round, you might be off by, 1 meter. Like you could potentially round to 73 or something like that. Okay, so anyway, but look again. So the whole point of this video was to look at my working here. I show all my working, and so if I had made a mistake, even if I had prematurely rounded and subtracted wrong, I still would have gotten most of the marks. Okay, that's a 6-mark problem. Okay, well there you go. We'll move on from there. Okay, number 3 here is going to be quick. I just want to go over graphing really quickly. This is IB graph paper, okay? If you look at it, basically, these boxes right here, these represent 1 centimeter, okay? Now, the IB will always give you, well, not always, but most times when they ask you to draw a graph that requires graph paper, they're going to give you a scale. And these graphs usually are like 4 marks, and it's again, it's points you shouldn't give away. Now, here's how they work. Now, in this case, I said on the x-axis, I said 1 centimeter equals 5 degrees Celsius, and on the y-axis, I said that 1 centimeters equals 25 visitors. Okay, this was a correlation problem, which actually doesn't matter. Okay, but so the point here is this. Look, I used pencil when I did this. Okay, so first, number 1, use pencil and use a ruler. Okay, make sure you have that going into an exam, or make sure you ask for it. Okay, so I have straight lines here. I have the scale which they've used. Now, another thing is, look at this right here. I've labeled the axes right here, temperature, and I labeled visitors. Okay, kids often forget to do that. Okay, so make sure you do that. That's 1 mark right there. Okay, then I plot the points right here. Okay, that's a couple marks there. And then normally what they'll have is you draw a line of best fit. So the line of best fit would probably go like right here and through the mean point, which I think is somewhere like right here. Anyway, if you're going to draw that, make sure you use a ruler. Now, it's not going to be straight if I draw it because I can't use a ruler on this thing. Well, there we go. But close enough. So anyway, you would draw that with a ruler. Now, label your axes, okay, and use the proper scale. And they will say it in the, again, 1 centimeter is just 1 box right here. And there's 5 little boxes in each box. So, for instance, if this goes by 25, so each box represents 25. So when you're plotting the points, you got to be careful a little bit, okay? Now, and then the last thing is, if you're going to draw a curve, make sure it's smooth, okay? Now, in this case, you wouldn't have a curve, but let's, for the sake of argument, let's just say you had, some points, you had some random function or something like that, and it went like that. You'd want to make sure you draw a smooth curve, okay? A lot of kids try and connect the dots. Okay, this isn't kindergarten. These are functions, so they're going to be a smooth curve. Okay, again, this is one. Don't give up points on this. Don't make your own scales. Just follow what they say. Get your 4 points and move on. Okay, this is like paper 2 type stuff right here. normally a function or like a function problem, a calculus problem, or often a statistics problem. They might give you a cumulative frequency curve or something like that. Okay, not a big deal, but again, just be meticulous about it and you will be good to go. Okay, let's move on. Okay, for this this part of the video, I'm going to go over timing, and on timing, you just got to make sure this is a paper 1 problem. It's 6 marks, so each mark is supposed to take 1 minute. So this problem should take 6 minutes. Okay. Now I've seen kids struggle on some of the. This is a calculus problem. The later problems, questions 13, 14, 15 on paper 1, are normally the hardest problems. And I've seen kids struggle, spend 20 minutes on a problem, and then not be able to finish their test. So just be careful about that, okay? So manage your time. Like when you get your reading time, that's really important. You want to come up with a strategy. Do the ones that, look that you're real comfortable with. Do those first, then tackle the harder ones, okay? Now, in this case, it says sketch, so this should take me no longer than 6 minutes. A sketch of the function f of x equals 5x to the third minus 3x to the fifth plus 1 is shown. Okay, and then they restrict the domain here and the range, which is nice because we'll be able to look at this on the calculator. Okay, so write down f prime of x or the derivative. Okay, these calculus problems always start the same way. So let's do 3 times 5 is 15. X, take 1 away from the variable, or exponent, excuse me. So it's 15x squared minus 5 times negative 3 is negative 15 x to the fourth, and then 1 stays the same. So that's our first answer there. So 5x squared minus 15x to the fourth. That's our derivative function, or what's also called a gradient function. So any value of x we plug in here will give us the gradient at that point. Okay, so now find the equation of the tangent to the graph of y equals f of x at 1, 3. The important part here is they give us an x value, which is 1. Okay, and then obviously the y value is 3. So we'll just do f prime of 1, and we just sub in 1. Okay. Now this one's actually nice because it's going to be 1 times 15. It's going to be 15 minus 15, so it's going to be 0. Okay. Now anytime you have a gradient of 0, it's a horizontal line, and it goes through 3. So the equation is going to be y equals 3. But let me just show you, if you didn't know that right off the top of your head, you could do the y equals mx plus c. This is good practice anyway. 3 equals m, which is 0, x is 1, plus c. So c is going to equal 3. Okay, so then you would write y equals 3. Okay, so basically what we have is we have a horizontal line at y equals 3. Okay, and that, when you have these horizontal lines, this represents a minimum and a maximum. So this line is right here. Okay, so we just found this point right here. Okay, this would be 1, 3 right here. Now, the reason I know this is, the y-intercept of here is going to be 1. So this is 1 right here. So what we need to do is, for part C, it says write down the coordinates of the second point. So we need to find this here. Now, there's a couple different ways to do this. I can plug, I can plug y equals 3 into here and solve for it, but I don't want to do that. That's a complicated function. So what I'm going to do is I'm going to use the calculator. Okay, so what the first thing I would do here is I would go to y equals. Okay, so here, let me start from I've already entered this in. So I'm at the home screen, I go to y equals. Now I entered in, you don't enter in the gradient function, you enter in the first function, okay? So 5x to the third minus 3x to the fifth plus 1. And then I also entered y equals 3 because I want to see where they cross. Now, they restricted the domain and range here. So I'm going to go to my window. And again, I've already changed this, but it's negative 1.5 to 1.5. And I'll leave it as 1. I can change that later if I want. And negative 6 to 6. So I'm going to graph that and see what it looks like. Okay, so I've graphed it, and it looks exactly like what we have here. We know this point here is 1, 3. We want to find this point. So what I'm going to do here is I'm going to go to second calculate, and I'm going to calculate an intersection, which is 5. Okay, so I'm going to go down on the first curve. Okay, so you just go to the intersection point. right here. I'm close to it. Press enter. Second curve, it's right near there. Enter again and guess. Yes, I want to guess. And it's negative 1.383. Okay, so negative 1.383. So there's really no working to show there, and you'll get a C2. So it's, remember, put brackets, 1.383. Okay, so again, time management really important. I don't know how long that took me, but I don't think it took me 6 minutes. Okay, and just come up with your strategy, and you should be good to go. Okay, and this little review of calculus for you too, which is nice. All right, let's move on. Okay, for this last thing here, it's not really a mistake, I guess, but just, your calculator is your friend is what I titled this, and it's true, man. If you know your calculator, it helps you so much. And I'm gonna do a couple problems here. I'm gonna do a function problem, and I'm doing a probability problem. There's not a big calculator component here, but I just wanted to do a probability problem because my kids kind of struggle on it sometimes. But I'm just going to go through, I'm going to go through a couple problems here and just use the calculator. And the more familiar you are with it, the better off you'll be. So it says Alan's laundry basket contains 2 green, 3 red, and 7 black socks. Okay. He selects one at random. Okay, so Alan is a nerd. Okay, who sits there and selects random socks from their laundry basket? I don't know. I think the IB should use more relevant problems in this, to be quite frank with you. I would use, having worked in Las Vegas as a poker dealer at one time, I would use gambling problems, but I know that's not cool in some parts of the world, especially where I worked, so whatever. Haram, got it. Okay, so anyway, Alan's laundry basket contains 2 green, 3 red, and 7 black socks. Find the probability that the sock is red. Okay, so there's red, there's 3. Probability is part out of total, so it's going to be, just 3 out of the total, which is, okay, so what do we got? 2 plus 3 is 5. It's going to be 3 out of 12. Now, you do not have to reduce this, okay? So some kids will reduce it. Even if you reduce it wrong, they'll still give you marks for it. Yeah, but, if you're looking on the calculator, now, let's say you're back at the home page here, and, it's, 3/12. Okay, if you want it as a decimal, it would be 0.25. Now, let's say you had the decimal. This is just one thing that's kind of nice to know. You can go to math and you can turn it back into a fraction. 1/4. That's how you reduce something. But anyway, you don't have to reduce, but it's just something to know on the calculator. Okay, now what I'm more concerned here with are the second and third problems here, okay? So it says find the probability. Okay, Alan returns the socks to the laundry basket and selects 2 socks at random. Okay, so anytime they do select 2 kids, 2 socks, whatever, this is non-replacement probability. Okay, so a lot of kids get confused about this, replacement versus non-replacement. He's selecting 2 at a time, which means technically he's selecting one and then selecting another. So he's not putting the first one back. So that affects the probability. So find the probability that the first sock he selects is green and the second sock is black. Okay, so the first sock is green. So that's going to be 2 out of 12. Okay, now this is another common mistake. When you do independent probabilities, you have to multiply. Okay, and then the second sock is black. Okay, well, there's still 7 black socks there, but he took, a green one out. So there's only 11 here. Okay, now this is 14 out of 132. Okay, which is, I'm just going to leave my answer here. Okay, but again, you can use the calculator if you want. So, to do fractions on here, I would just do, 2 divided by 12 times 7. Ooh, whoops, I'm going to put brackets. I like to put brackets. That's a good strategy. 7 divided by 11. Okay, and all right, here you go. And then if you want to turn it into a fraction, just go math, fraction, boom, 766, or 14 over 132, same thing. Okay, now if you're going to put it as a decimal, which is fine, you can do that. Just put 0.106, do it to 3 significant figures. Okay, And then finally, the reason I'm doing this problem is because I like this last problem, okay? So it says Alan returns a sock to the laundry basket and selects 2 socks at random. Find the probability that he selects 2 socks of the same color with color spelled wrong. Okay? No, I'm just kidding. I use American spelling, whatever. Okay, so basically what you got to think of this, we gave this problem once on a test, and not, I don't think anyone got it right, maybe 2 people. And here's the thing, okay? So let's think about this. What are the possibilities that can happen when he has these socks, okay? So, he can get green red, he can get green black, okay? Or he can get green green, okay? He can get, red red, red black, red green, or he can get, black black, black, red, black, green. Okay, there's 9 possibilities here. Now, if you look at it, what are the 3 possibilities of selecting socks that are the same color? Okay, there's 3 possibilities here. So we already found, actually we haven't found anything. So we got to find all 3 of them. So the probability of green green is going to be, in my work, I would just make an arrow up there. Green, so it's going to be 2 out of 12 times 1 out of 11, which would be, 2 out of 132. And then the probability of red, which would be 3 out of 12 times 2 out of 11, which is 6 out of 132. And then the probability of black is going to be 7 out of 12 times 6 out of 11, which would be 42 out of 132. Okay, and then you just have to add all these together. Now, if you don't know how to add fractions, just don't worry about it. Do it on your calculator, but all you have to do is, 2 plus 6 is 8, plus 42 is 50, so it's going to be 50 over 132. And again, you can use the calculator to add those, okay? So anyway, I wanted to do this probability. Not a lot of calculator work in this, but I just wanted to do this problem and show you, you can do converting to fractions here. We'll move on to a function problem next. Okay, so this problem right here is an exponential function, and I'm going to show you how to do it a couple different ways on the calculator. It's really, anytime you see one of these, it's straight calculator work. So it says the number of bacteria in a colony is modeled by the function n of t equals 800 times 3 to the 0.5 t power, where t is greater than or equal to 0, and is the number of bacteria, t is the time in hours. All right, so write down the number of bacteria in the colony at t equals 0. Okay, well, for this, we can just plug in t equals 0. So we would just do n of 0 equals 800 times 3 raised to the 0.5 times 0 power. Now, you don't even really need a calculator to do this. Like 0 times 0.5 is 0. Anything to the 0 power is 1. So it's going to be 800 times 1, which is 800. Okay? So I'm going to just put 800 here. Now, if you need to use a calculator, no problem. Okay? We'll just go 800 times 3 raised to the 0.5 times 0. Okay? And you get 800. Okay, so we're good to go on that. Okay, pretty straightforward. That's the y-intercept. So basically it's the initial number right there. And then, okay, calculate the number at 2 hours 30 minutes. So that's 2.5 hours. Okay, now, one thing, if you want to turn, hours, like 30 minutes is easy. Like 30 divided by 60 is 0.5, right? But, if it's a different number, like 2 hours and 45 minutes, you didn't know, you need to turn it into a decimal, just divide the minutes by 60, and that will give you the decimal part. Okay, so calculate so again, I would do n of 2.5 equals 800 times 3 to the 0.5 times 2.5. Okay, and I can't do that one in my head, so we'll do here. Okay, and just do 800 times 3 raised to the 0.5 times 2.5. And look at that, I didn't put multiply, so that would have been a disaster. Okay, it's not a disaster, but it would have given me an error. Okay, so what do I get there?
3158.58. Okay, so 3158.58. 3158.58. However, they say give your answer correct to the nearest 100 bacteria. Okay, so in that case, the hundredths place is right here, so we're going to round up. So it's going to be 3,200. Okay, so again, 3,200 is your answer right here. Okay, so, and I mean, I guess you could label these. You wouldn't get bacteria. I don't think they would they don't take off for that, but if you want to be a stickler about it. Now, calculate the time in hours for the number of bacteria to reach 5,500. Okay, these exponential problems always work the same way. They ask you to find a couple here, and then now they're giving us the y value. So we need to plug it into this side. So we're just going to do 5,500 equals 800 times 3 to the 0.5 n. Okay, now you can use logarithms here if you want. It's not in the math studies curriculum, so I'm not going to do that. What I'm going to do is I'm going to use the math solver, which really comes in handy in this case. To use the math solver, you have to make this equal to 0. So what I'm going to do is I am going to take this right here, and I'm going to move it over here. Okay, so when I do that, I get 0 equals 800 times 3 raised to the 0.5 n power minus 5,500. Okay, now I'm going to use the solver. Okay, so this is a good trick to use, especially for exponential functions. Okay, so you go math and you go to solver. Okay, now look, it's up there, x equals 10. Okay, so what I have to do is I have to arrow up. Okay, and I'm going to clear this and I'm just going to enter it in. So obviously you've seen that I did this problem wrong the first time. So 800 times 3 raised, I put 5,000 instead of 5,500. So if it had been 5,000 bacteria, I would have been perfect. 0.5 times x, and then make sure you put brackets, okay, so it knows to raise it to that, and then minus 5,500. Whenever you're in doubt, just put brackets, 5,500. Okay, and I'll press enter, and then you have to do alpha and solve. And so I get 3.51. Okay, so to three significant figures, it's 3.51 hours. Okay? Now, you'll notice I did that all straight on the calculator without even looking at the graph. But I want to go through this again, kind of looking at the graph, okay? Just to, it never hurts because sometimes you have to graph these, okay? So let's get out of here and let's go to, okay, so what I did is I entered it into the y equals, okay? And I'm going to graph it. And what you'll notice here is I can't see it, okay? And that's very common with big numbers, no problem. You can't really, the zoom function on here is not very good. So what I'm going to do is I'm going to go to the table. I'm going to go second table. I'm going to go second table at some point. There we go. Okay, so look at, it starts at 800. Oh, 0, 800. Like, look, that's our answer right here. Okay, now wait, what if I wanted the 2.5? How could I get the 2.5 here? Well, I could just go, see this plus sign for the table change? I can just do plus, and I could have it go by 0.5s. And look what happens there. Ooh, there's my 2.5, 3158.6. Okay, see? So I got the answer there. So it's pretty nifty. Okay, so let's see what I want here. I'm going to go down. I only want to look at like the first 5. Maybe it goes up to about 13,000, 12,471. Okay, so what I'm going to do is I'm going to change my window, and so I'm just going to go like 0 to 5. I don't really need to see much beyond that, 5 hours, and X sales 1. That's fine, and then Y minimum 0 to, I think, what was it, 13,000 or something like that, and I'll go by 1,000. Okay, so it's really good to be able to change the scale here. And now when I graph it, I should be able to see it. Okay, so you can see it's exponentially getting bigger. Okay, now you can calculate X values on this by going to second calculate value. And I can just do 2.5, which is part B here. And boom, it gives me the answer. So see how it plugs it in there, which is kind of nice. Okay, now the only problem is with what some kids try and do here is, like, for this answer, they'll try and trace. and they'll go, oh, okay, well, I can just trace this right here. And they'll go up till they get to 5,500. Now, the problem is that's not close enough. You would technically get the right answer there, but I would be real careful doing that. It's not accurate enough. I think the solver's a way better approach there, personally. So anyway, there you go. But again, so what did I show? Just what do we got to take out of this in terms of calculator use? Well, for exponential functions, look at the solver. Okay, changing the window on to see a function, looking at the table, using a calculation. You can calculate a value. The minimum and maximum, those are great for calculus problems. The intersection we just did on another problem. You won't really find the gradient and derivative and all that stuff. I wouldn't even use that. Zeros, you can find where it crosses the x-axis, but there's actually better ways to do that with the apps function. Oh, I don't have it in here, but with polysimultaneous too. Okay, anyway, that's it for now, and I'll move on to another problem. Okay, so what I'm going to do here is I'm going to go over some last minute skills here for you. Let's say we're given a quadratic function like f of x equals x squared minus 2x, minus 8. Okay, it's really nice if you look at, that's not what I meant to do. I'm making the video there. If I enter this into the y equals and, I press zoom 6, which is zoom standard to graph it, you see the graph right there. Now, with all these functions, what these problems are going to ask you to do is to analyze it. Now, they might, for instance, ask you to find the minimum point or the vertex. Okay, so the minimum point you can calculate, calculate, and go to minimum. Okay, and so that's the left bound. So you go to the left of the vertex, press enter. You go to the right of the vertex, and you press enter. See how it's going to guess in here. Press enter, and guess. Okay, so it's 1, -9. Okay, sometimes you have to round there, but they're normally whole numbers. So the vertex here, the vertex is 1, -9. Now they might ask you what the axis of symmetry is. Well, it's always the x-coordinate of the vertex. Okay, so it's going to be x equals 1. That's our axis of symmetry. Okay, now you can also look at this graph and see where it crosses the x-axis, okay, or solutions. Okay, so I can calculate. I can go second calculate, and I can calculate zeros. Which so I'll go left bound. The only problem with this is you have to do it twice usually. So left bound is right here, and then the right bound is over here, and guess. So that's -2 and 0. So one of my solutions is going to be -2, 0. And then I can go over to the other one. But let me show you how you can do this another way. Okay, so if you go to apps and polysimultaneous 2, you should have this on your calculator. You can go to poly root finder. Okay, and it should be set up. It's an order of 2. So if it's to the third power, if the x is to the third power, you just change that to 3. And we can enter this in. It's just enter in the coefficients. So it's going to be 1, -2, and -8. Okay, and we just press solve. And so what you'll see is I already had the -2. The other one was 4. Okay, I mean you could have factored this too, but you don't have to factor anymore in the studies curriculum. Okay, so there you go. Those are your two solutions. Okay, so what you see a lot is you might get a calculus problem where the graph looks something like this, where there's a a minimum and a maximum. And it really is very useful to find these, the local maximum would be right here, local minimum would be right here. It's really useful to get these on the calculator. I did an easy function, but to graph them for, you can change the window if you need to. Oh, I need to get out of here, sorry. You can change the window if you need to, and then graph them, and so you can see your graph. If we had one like this, you could calculate the minimum and the maximum, and I mean, you can do it by hand, but if it's easy to use the calculator. Now, another thing you can also use the calculator for is sometimes you'll get simultaneous equations, and within a context of a problem, they'll actually have you set up simultaneous equations. And I've done these on other videos, so I'm not gonna go through it. But let's say you had something like this. And 3x plus 4y equals 11. Now, you can solve this algebraically if you want, but, they let you use polysimultaneous, so that's what I'm going to use. So I'm going to get out of here, and I'm going to go back to apps, and I'm going to go to polysimultaneous, okay? Now, in this case, it's not polyroot finder, it's simultaneous equation solver, okay? There's two equations, two unknowns, and I'll just go to next. And then you enter in, again, the coefficients. So it's a great tool to have. And if you don't have it, put it on your calculator, okay? And it's allowed. Trust me, I've researched it. It's allowed. Boom. And just solve it. Okay, so x is 2 and y is 1. So or excuse me, x is 1. X equals 1 and y equals 2. Okay, so you see how quick that was? I mean, I could have done the algebra, but why waste your time when you can use the calculator? Another cool thing to do is, just with statistics, you want to make sure you know how to enter in lists. So you just go stat and edit. In this case, we have 2 lists. Okay, I just made these up off the top of my head. 1, 2, 3, and 4. Okay, and 10, 11, 15, and 8. Okay, now make sure you enter them right. Like I can see that I made a mistake there, so I'm just going to put 15. Okay, now let's say I wanted to find the mean of this. Okay, so I could go to stat, I could go to calculations, one variable stats, and the list 1, and then the frequency list would be L2, so that's L2 like right there, and I could just calculate. And the mean there is 2.47. Standard deviation, if they ask for that, is 1.03. If they ask you for a box and whisker plot, you've got your 5-number summary that can make the box and whisker plot right there. Nice and easy. Okay, now what if this is a 2-variable stats problem? Okay, start the same way. You still enter all your stuff in. So again, enter in your lists. And you go to stat calc 2-variable stats. Okay, so and now I don't want a frequency list here, so I would have to clear that out. And what do I got? I got the mean of the x. Now this would be if I wanted to do a scatter plot or something like that. So the mean of x, the mean of y, etc. Okay, standard deviation. Now, and then I can also do I can find the linear regression line, which is calc 4. Okay, and linear regression line, calc. Now, look at that. So if my line of best fit right here is it's negative 0.2 and 11.5. So it's y equals negative 0.2 x plus, I think it was 11.5. Okay. Now the problem is there's no r there. Okay, so this is what you got to do. You got to make sure. Now we do this for our kids. We turn on their diagnostics, but if your diagnostics aren't turned on, you should do it when you start a test. So second catalog, and just arrow down to diagnostics on. This will give you your R values so you can see the correlation coefficient. Okay, so keep going down. It says diagnostics on. Okay, boom. Just do that, and then we'll go back and calculate it again, and look how it's different. So it's going to be linear regression. We're good. Now you can store all this if you want. I wouldn't even bother with that. You can store it in the y equals, but you don't really have to do that. So our R is negative 0.08. So it's not a very big correlation at all. In fact, it's close to 0. But that's all right. Okay, so make sure your diagnostics are on, and that will get you through stats, just knowing how to do that. Okay, and then finally here, just one last thing. I just want to go over a normal distribution problem, and I'm just going to make it up. So let's say you had a normal distribution problem with, your mean is 100 and your standard deviation is, that's horrible, but whatever, 10. Okay, what they'll often ask you to do, now this happens to be IQ scores, so whatever. It's not a reliable test, but well, maybe it is, who knows. Okay, all I know is I'm getting dumber as I get older. Okay, so if this is the mean right here, you can, they often ask you to draw a graph. So one standard deviation above the norm, or of the mean would be 110, and then 120, 130, etc. 90, 80. Now I don't know if this is the exact thing for IQ, I've heard once before that it was standard deviation was 10, but I don't know that that's right or not. So anyway, you know, and then let's whatever IQ scores. I should probably check this, but I don't really care, to be honest with you. Okay, so you know, now the type of problems they'll ask here is, you know, they'll say, what is the probability, you know, that they score less than, you know, a 99. Okay, so in this case, you would go to, and kids get these wrong a lot. So I think it's because it's new and we don't focus on it a lot. So you go to second distribution and you go to normal CDF. Okay, and so we're finding the less than. So we're basically going, you know, if you're gonna, whoops, that was not what I wanted to do. Second distribution, normal CDF. I was trying to change pen colors. You know, we're basically going from 99, which is here, 99. So like is like right there, and we're finding this, right? Okay, so what you'd do is you'd go, you always put something really low, so it defaults to -1 e to the 99, which is fine. And then, you know, we'll press enter, and we want, you know, what we do, 99, and then the mean here is 110. Okay, and just what is going on here? This is the only problem with distribution. Is sometimes it messes up like this. Okay, so normal CDF. Okay, there we go. So 0.46. So 46%. You know, or just you could just put 0.460 to three significant figures, or less than 99. So you know, 0.460. Okay, what about greater than, you know, 123? So, you know, let's say greater than 123. Okay, so 123 be right here. We're finding greater than. Okay, and so probability, you know, greater than 123. Okay, and again, so you would go to normal CDF, and I always clear this because sometimes it gets like, it was funky like on that last one. So do a second distribute normal CDF, and this time they give you the lower bound, so it's going to be 123 here, and then you got to enter something really high. So I just do 1 second E99. Now the mean and the standard deviation are the same, so we'll see what goes on there. And it's just 0.107, so not very high. Okay, so, you know, a little over 1%. Was it 0.0107? Yeah, so, okay, so 0.0107. So that's just greater than 1%, okay? Now, you can also, you know, if you want to find between, like, let's say you want to find between, you know, like 105 and 115, you know, again, this would be your lower bound, 105 and 115. You do it exactly the same way, okay? Now, the other thing they'll ask you is they'll give you the probability. So in this case, they'll say, like, so the probability, you know, is, you know, I don't know, 0.3 less than X. So they're asking you basically to find this number here. So they want you to find the area under the curve. Okay, so anytime it's less than, this is called the inverse normal. Okay, so you go second, and I'm going to clear it. Second, distribute inverse normal. And the area under the curve here is 0.3 because it says less than. It always calculates the less than. The mean, again, is 100. Standard deviation is 10. Boom. And it's, you know, the answer there is 94.8. So what they're saying is, like, 94.8 would be, you know, like right here in the middle. And, you know, that represents 30% under the curve. Okay. The only trick for this is that if they said probability, and then they do this sometimes, you know, is, you know, 10% greater than X. Okay, so this, they would probably do 30% here, and you'd have to do 0.3 greater than X. Now, anytime they do a greater than, now when you find, here, let me draw another one because it's getting a little Whoa, that is rough. Anytime they want that you're using inverse normal, you're finding the area to the left of the curve, or to the x value here. Okay, you're finding the area to the left. Now they say 10% greater, so they're talking it's 10% right here. But we want to find this. So that's the only trick. You just have to do 100 minus 10, which is 90%. Okay, so again, we'll just go back to the calculator and just clear it and go second distribute, normal distribution. Inverse normal, sorry. And then 0.9, and then boom. And it's 112.8. Okay, so what they're saying is that, at 112.8, which is right here, it's 90% to the left. Okay, and 10% higher. So 10% or higher than 112.8 or 113. You do the three significant figures. Okay, now the only other thing is they might have you find expected values here. Okay, let me get a different color pen. Let's go with red. Okay, so the expected values. Now, let's say, there are 200 students, let's say, or students is a bad one since I was talking about IQ. You don't really do that. But 200 students, and, what's the probability that they score between, who knows? Let's make them smart. If you believe in IQ tests, 110 and 120. Okay, so in this case, you would find the probability. Okay, so you go second distribution, normal CDF, and then again I do 110 and 120. Not 1200, 120, and then again same 110. Okay, and boom. Is 13.5%. Now, they want the expected number of students, so I would just multiply by 200 at this point. That's the only trick to that. And it's 27. So you can't have a 0.18 of a student, so I would just put there 27 students. Or you could say 28. They'd probably accept both answers, but I'd say 27 students. So you'd expect 27 students to be in that range. Okay, so anyway, that is normal distribution. And, just looking at the calculator, I don't know. I think I've gone over most of the stuff here. So, if you're clear on this stuff, and I don't know. I mean, you know how to do a chi-square test. You just enter in the matrix. Over here, you know how to analyze functions on the graphs. You should be good to go. If you ever run into trouble, you can go to second memory and just you can reset it, the calculator, and if you run into trouble. If you are in stat and you delete a list by accident, if I want to clear this, I should say clear. Okay, I should say clear and enter. And I can go clear and enter. Okay, what happens is a lot of times kids will go, oh yeah, delete the list. Looks, there's no L1 right now. So what I just do is that if that happens, see this insert button here, just go second insert, and I want it to L1, so I'm just going to go second L1, boom, enter, and it's back. Okay, so don't let that, sometimes kids get bogged down with their calculator, and you really don't want to. The calculator's your friend. Okay, anyway, that's all for now. Hope this helped out, and best of luck to you on your exams. Take it easy.